Alright, in this video we're going to carry on with the series. We've already made the skeleton of the program and made the black screen, you know, everything to make a window pop up. We've talked about the makefile. We have created the window icon and the background. So in this video we're going to be making the actual player. So we're going to make a new module that's going to hold the player. It's going to be called we're going to need two new files, player H and player C. So let's make those first. Player C and player H. Okay, and we'll go in and we'll right away we'll make the include header guards for this. If in def player player.h and include okay. So we need to pull in main.h. If I put a pound sign in front of this. And we will be making a struct to hold the player that is going to hold the render, a local pointer to the render, a local pointer to the image, the texture. It will also be holding the keyboard state, and it will be, yeah, we'll just start from there. So let's make that. So the first thing is the render, and we've already seen what this looks like. And now this is just going to be a local pointer so that this player can draw itself. So we're going to be passing this in. And the same with the image. It's going to be managed in the game module, so this is just going to be a local pointer to it. We will need a rect that we will make right here. We will need the, let's look at this function real quick. This SDL get keyboard state, this gives us a pointer to an internal SDL array. And that array we'll be able to access it with the scan codes, and the scan codes are basically enums that can be used to index into this array for a specific key to know if it's 0 if it's not being pressed down, or 1 if it's in a down state. So we are going to be using this function to populate the pointer, and we will be holding it here in this and the player rect as well. We'll call it key state. So key state, that's probably good for that. So now let's talk about the functions that we're going to need initially. So we'll have a player new function that will be creating the new function, and we'll be passing in the render and the image to it. We'll have a player free, we'll have a player update, and a player draw function. So they're all going to be void functions except for the player new, which is going to return a Boolean because we are going to be querying the texture to fill in this rect. So the first one will be a bool. We'll go player new. And this one is going to be the player. And it's a double pointer because we are populating we're actually putting the player on the heap at this time, and we're actually changing a pointer that is outside of this function. So we need that pointer to the pointer. And we're also going to be having an SDL render passed in and an SDL texture. We'll just call it image. So the free is going to be a void, And that is just going to be the same, the struct, the pointer to a pointer. That should be player up there, not play. And a void for player update. And this is just going to be a normal pointer. And a draw function. And in this draw function, we could test if the drawing failed, but since it's a game and it's running 60 times a second, the drawing is not as important, so I'm going to skip the drawing test. So it's just going to be void for the return on this. Okay, so those are some functions to start out with. So we'll grab these. We expected. What did we expect here? Oh, I always forget the semicolon right there. I'm going to save this file. Now let's go to player C, and we need to include right away the player.h. And I will just put those in there here. I'm just going to populate the squirrely braces real quick. So this needs to return false. And this will just be some braces. Okay, so this is actually what we're populating here is actually going to be the player, the pointer to the player is actually going to be held in the game. So I'm going to jump over to the game struct and make that happen real quick. So in game H, we're going to need, we need the actual, the image that the player is going to have. We're going to be managing it here. So we need the texture. And we're going to call it player image. And we need a, so we need the pointer. This is where we're going to hold the pointer of the player as well, the actual player struct. So the player struct is defined in player H, so we do need to include player H here. Okay, now we can go down here and we can make a pointer to a player. Okay, so the player is going to be managed by itself. It's going to be told to clean itself up, but the image is actually not going to be in the player. The image is here, but it's going to be holding a pointer to it locally. So let's save this and go to the game C real quick. We need to run the player new from here. So after we've loaded media, we haven't actually told load media to load the player image yet. So we're going to be jumping there too, but let's just populate this and then show how that the cleaning and the launching of this is being done, and then we'll kind of be moving around a little bit. So this is going to be an if statement, and we'll say player new, and we need to pass in the actual player. It's going to be the address because it's a pointer to pointer, remember, so it's going to be G player. And then we also need to pass in our render, which is just G render. And we need to pass in the player image, which is going to be G player image right here. And if that fails, we're just going to return true. We're not, the error messages will be in player wherever it failed. This is just receiving whether it failed or not. So we're just passing this on down the line. So that's going to be how we create the player. How we clean up the player, we're just going to tell player to clean itself up. So we'll do that right at the top up here. We'll say player free, and we need to pass in the address because we need that pointer to pointer. So it's going to be G player. So that's telling player to free itself. Okay. We also need to tell the we also need to clean up the player image here, because even though the player is cleaning itself, the player is not going to clean up the player image. We're going to be doing that here because this is where the real image is being held. Destroy texture, and that's going to be the player image, and we'll set it to null. Player image equals null. Okay, so we're destroying it here. We're freeing the player and destroying the texture. Okay, we haven't actually loaded the image yet. We should do that real quick, and then we can get back to the, so it's right here in load. And we're just going to be doing this exact same thing right here. And I'm not going to be querying it here. I'm actually going to query it in the player because I just need the rect inside the player. I don't need it here. So it's player image, and the image it's loading, let's look at it real quick. So images, and it's just called player image, or it's just called player rather. There's player, and we need to check player is good. Error loading texture, it's an image thing. Yes, yes, that's all good. So that is going to be the way we reload the player image. Okay, I'm just going to save that. So we are loading the image. We're definitely destroying the image. We are, let's go into game again. We are initializing right here, player new, and we are cleaning, we're telling player to clean itself up here, and we are destroying the texture that we're loading here. So now back into player C, now we can actually create player. So it's going to be a calloc. So we'll say we need to dereference player, and we're going to equal calloc, and we only need one of them, and it's going to be size of struct player. And then we need to check to see if that really happened. So we're going to run if, let's see, we'll do the if star player equals null, because I don't want to put a bang in front of the star. So we'll do fprintf, std error, say error is it error in calloc. I want to use the same wording that I used in the other objects. So we have error in calloc of game. I'm just going to take this right here. And where is player C at? There it is. I'm just going to put this right in here. Okay, so error in calloc of new player. Okay, error in calloc of new player, returning true. We'll do the thing where we make the P, make the pointer to the player as P. star p equals dereference player. Okay. Now we need to do a couple things. Let's see. We need to set the render. We need to set the player, or not the render and the image that were being passed in. So we can do that just by linking them up, basically. So we got p render equals render, and then p image equals image. And we also need to populate the key state. So we can say p key state. And now this one we need to use the function over here. So this SDL get keyboard state, this is going to return that pointer to the internal array that we need. And we're going to be passing null into it because we do not want to set receive the length of the returned array. We don't care about that. So we're going to be passing null in here. We just want the pointer. Let's grab it. So we're going to have to write it. So that'll be right here. Okay, and we don't need to manage this because this is a pointer. This is returning a pointer to an internal SDL array. SDL is managing this for us. And I'm not sure if I explained it, but this array is your keyboard. And the scan codes are actually an enum that is used to index into this array. And it returns a 0 or 1. The 0 means the key is in an up state. The 1 means it's in a down state. So by indexing this array with the key that we're looking for, we can get a return whether it's been pressed or not, or it is being pressed or not. So it's not a keyboard event, it's just a keyboard state. So we have our render, we have our image. We need to populate our rect. So let's do that. And this can fail, so we're going to do the if. And we'll go SDL query texture. It's going to be p image. And we do not need these two things. They're going to be null. And we do need the address to the rect. Did I make the rect? Yeah, I think so. Address to p rect. Okay, that looks right. And this is something that can fail, so we're gonna return an error from here. Just grab this real quick. Now we need to say, we need to get the error. So we'll say error querying texture. Texture. And we'll do this, %s, and we're going to get the SDL get error. It's a function. So that will give us our error message, and then get the real error message that occurred, and return from here. Okay. So the freeing of the player, let's look at this. So this is just kind of a small game. We are letting player free itself, but all it really needs to do is do the calloc, free the calloc, but we're going to let it nullify the pointers as well. So first we're going to check to make sure that it is actually populated with calloc before we try to free anything. So we're going to put an if statement on that, and we're going to see if it really exists. And since this is small, I will just use the star, the dereference player, instead of making my own star p. So I'm just going to use this each time. So it will be, so that's not right. And player image will be set to null. Again, I'm not managing this image. I'm just setting it to nulls. It's probably a little bit over the top, but I just want to do the best practice with the code. So there's the render, and the last one is the key state. Key state equals null. Now we actually want to free the player. And there we go. So this will actually free the player from inside of itself because it passed in the pointer to the pointer, and it will actually nullify the player pointer that is in the game struct. So the game struct is holding that the player pointer, but since we passed in a pointer to a pointer, we get the address of that pointer. We can nullify it from within this function. So we're freeing it, but not letting that pointer dangle in the game struct. We're gonna set it to null. So that's going to be taking care of freeing this. Let's talk about drawing this guy. So we have been using SDL render copy, and render copy is pretty nice, but I want this image to flip. So render copy doesn't let you flip, but render copy EX does. So let's look at that real quick. Is this it right here? Yes. So SDL render copy EX allows you to do a couple things. It allows you to rotate, it lets you to choose the axis, the center point. It allows you to rotate around it. It allows you to also flip the image. Let's see here. So we need the render, we need the texture, source, destination, rectangle. Those are standard. Now we have the angle. We're not going to be using an angle, so we're going to leave this at 0. The center, we actually want it to flip on the, I know the origin of the image is the top left, but we don't want it to flip on the top left because then the image would move on the screen every time it was pointing one direction or the other. So we want it to flip at its center point. So if we use null here, it's actually going to take the half of the width, which is going to be the center point. It's going to say it's going to calculate for us the center of this image and flip it on the center, which that is good. And here is the actual thing that we're interested in, is this flip. So SDL flip, is it here? Render flip. So we can either have none, not flipped, or we can flip it horizontally or vertically. And you can actually do both. We just need it flipped horizontally. I think that's right, horizontally. Yeah. So we either need it flipped horizontally or none. So that'll get us facing to the left or facing to the right. So this is what we're going to do here. So we're going to use this function right here, and we're not going to check if it failed because, again, this is just drawing to the render 60 times a second. So we're just going to say it's okay if it failed for a frame. We're just going to let it do that. I don't think it will fail at all, but if it did happen to fail, it doesn't need to shut the game down. It's going to be passed before it matters. So the render is p render. That's why we need our local, need to hold on to the local renderer there, or a pointer to it so it can do itself. This is going to be image. Source is going to be null, and destination is going to be our rectangle. Okay, angle is going to be 0. Center is going to be null. That will let it actually choose the center. And the flip is what we want. So we need a variable that's going to hold this flip. So let's do that real quick. We'll put it in the header file. So this right here, we need what we need is a SDL render flip is the type. Let's take a double check at it. Right. Whoops. I messed up that. Okay, so this is, yeah, right here. This SDL render flip is the type, and we're just going to call it flip. That's fine. So we'll put this in our struct as well. SDL render flip, and in our we do want to set it to something. So in our C, where we're making the game, right here, we can set it to something. And we're going to set it probably default to flipped, because the image, I believe, is facing to the left, and flipping it will face it to the right. That sounds about right, but we can either set it or unset it. It's not really going to matter. So we'll do that real quick. So we could say flip equals SDL, whoops, SDL flip horizontal. Okay, so that's set now. So now we can use this. There we go. So that should allow us to render the player image. Okay. And now we have called this already. Let me just double check to make sure it's being called. We are calling this to instance it, and we are calling this to free itself. Yes. Okay. So what we need to do is we need to tell the player to draw itself. So right here, we can just say, we have our access. I think we have access to player through. We'll just double check that in a second. So we need to say player draw, and we need to pass in the player, which is G player. Okay, so unlike this one where we're actually doing the work of it, player has the render copy X already in it. So we could just tell player to draw itself. And when we do update, we'll just tell it to update up here before the whole drawing thing. But let's just see if we got all those components correct. Make sure all these files are saved. Okay, let's try to compile it. Done quite a bit of code, so cross the fingers. Let's do a rebuild. Okay, we've made a mistake. Oh, this unused and player update. It's unused. Let's just comment it out real quick. So player H. I'm going to close this. Okay, there we go. So in player H, let's comment this out since we're not using it right now, because the compiler is going to talk about it being unused. And we'll do it here as well. Okay, let's try that again. Okay, and look, we have a snowman. Now we set it to flip by default, so what if we set it to none? Also, maybe we should move it. So let's think about putting it in the center of the screen and then maybe not flipping it initially, leave it unflipped. So player, now we've done this flip. I think we can set it to flip none. That should work on that. And we need to set this player in the middle of the screen, and we can do that with its rect. So what if we did p rect dot x. Now let's try to put this in the middle of the screen. So what we need is we need the width of the screen, we need the width of the player, and we need to divide. We need to take the width of the screen, subtract the width of the player, okay, and then divide that by 2, if that makes sense. So if this is the width of the screen from left to right, and our player, if we want our player to be in the middle, we need to think about we need half of the screen, but the origin of the x of the player is on the left side. So we need half of the player. So we need half of the screen and half of the player. So what we can do is take the whole screen, subtract the player, and then divide that by 2, and we get the answer that we're looking for. So the screen is it window? Window width, our pound defined from main.h. Window width subtracted by p minus p rect.w. So that's the player width. And this whole thing needs to be divided by 2. Okay. That should be, I don't think division turns it into double. So it's still an integer division, I believe. So let's see if that works. Unfortunately for the where the y should be, it's a magic number. And it's going to be around 377, I believe. Just a guess. With a semicolon would be good. So we have it unflipped. We hopefully have the X in the middle of the screen. We have the Y, so the snowman should be sitting in the snow. Let's try that. Okay. Yes, perfect. I want to press the left and right keys, but we haven't done that yet. So far we have the player on the screen. The player's drawing itself. The player should be cleaning itself up. We can check that in a minute here to make sure that is happening. And we can control left and right, sort of. We don't have any keys set up to do it. So let's just really quick double check to make sure that the player is cleaning itself. So why don't we just put in here, we'll put a printf statement. And we'll just say all clean. Okay, we'll put a period and a new line character. Make sure this guy is being cleaned up. And we can just run this. We don't need to rebuild it. It'll build what it needs to build. Okay, all clean. Now what if we tell it not to? What if we force a mistake here? So the calc never happens. Now we shouldn't see all clean here. If we see all clean here, we're going to see a segmentation fault or something. So we shouldn't see that. Okay, this is good. Error, this is our error message. This is the makefile saying it exited poorly, because we're telling it when we give this error message, we are saying, we are telling the return statement to be exit failure. And the makefile is saying, oh, it failed. Okay. But we are not getting a segmentation fault. So it did not try to free something that didn't exist. So that looks like it's functioning correctly. Okay, so let's talk about updating. What we really want is we want to know if the left and the right key have been pressed. And that's going to be down to checking that key state. So let's put that into the update. I'm going to go to the H file and uncomment it so we can use it. In the player, we'll just make it really simple at first. So if we want it to move, we don't have a speed set up. We'll do the if statements and we'll set the speed. So we'll do an if, and this is what it's going to look like. We'll get the key state. That is our array. And now we can index into this array by checking, by using the scan code, which is an enum. SDL scan code. And we want left, which is going to be the left arrow key. Did I spell this right? Scan code left. We'll assume that it's right. So if we get scan code left, we don't even need to say if it equals anything. We just, because if it's 1, that means it's being pressed down. So if scan code left, we're going to move our character to the left. So that would be moving the x position, the x, the rect's x, the x in the rect. We're going to increment that. Sorry, we're going to decrement it because the origin is the top left of the screen. So moving a bigger number is going to move it to the right of the screen. Moving a smaller number is going to put it off the screen to the left. So we need to decrement it. So we could say p struct rect dot x. We could say minus equals 5, something like that. That's going to be 5 pixels per cycle. Now, I'm not going to do an if else because what I want to happen is if I do an if and an else if, what's going to happen is if I have left pressed, it never checks if right was pressed. So if they're both being pressed, it's going to move left. If left is pressed, it goes left. If right is pressed, it goes right. If both are pressed, it still goes left. So what I want to do is do them both separately in their own if statement, so that if it does decrement and the other one increments, it actually doesn't move at all. Key state, and here's our array again. We'll say SDL scan code, and we'll go right. That's going to be the right arrow key. You can also use ASWD keys as well, and you can do both of them at the same time, just with an OR, a logical OR. Dot x, and we'll plus equals 5 on this one. Okay, so that's just really basic one, right? So we're just gonna see if that works. We're not checking bounds or anything. We need to call this from inside game C. And what we're gonna do is we're gonna handle this update right before all the drawing happens. So we're checking events, we're gonna do updating, and then we're doing drawing. So right here, we're gonna say player update, and we need to pass in the player. And this is a void. It's not returning anything out of it, so we don't need to check if anything has failed or not. We're just doing a little bit of math down there. So let's see what that does. Okay. Oh, I like it. I like it. Okay, so I can go back and forth, but my snowman doesn't face the direction I'm going, which I don't like that. So let's fix that. Okay, which way was the snowman facing initially? It's facing to the right. Okay. So his default is to the right, flip is to the left. So if we go up here to the player, so if we're going to the left, we need to flip him. So we'll say flip equals SDL flip horizontal. And if he's not, it's going to be flip none. flip none. Okay, and let's, for fun, let's add in the A and the D keys, just so you can see what that looks like. So we can just put an OR, logical OR on this, and we'll just do P, do the same thing, the key state. Oops, that needs to be, we're indexing it. Oh, it did it again. There we go. Scan, scan, scan codes. D. I actually want A, but that got me close. And we can do the same over here. So the double pipe, key state, SDL scan codes, and let's go A, and we'll change it to D. So that hopefully should give us the ability to use either one. Okay, I'm just running it. I'm just letting, it's only updating the one file. So here's left, here's right. See that? And let's try the A and the D. A, D, A, D. Now I'm going to press left and right at the same time, and I'm going to hold them down. So I'm holding them down right now. I'm going to let go of the right. I'm holding left. Okay. I'm going to hold them down again. I'm going to let go of the left. It's going to go right. So see, when I hold them both down, it doesn't move. He does change directions because the second test is being the right is being tested second, but it's good enough. That's pretty good. I mean, we can test bounds, so we can check, we can have it stop at the edge and stop at this edge. And what we want to do is, the problem is the image. If you look at the very bottom of the image where the snow is on the ground, that is the bounds for the left and the right. So it would actually stop here. Let me get a little, somewhere around here, or even further out. I'm not sure. But I actually want it to stop around here, where his face kind of touches the wall. I don't want him to be able to go off screen, and I want him to stop over here. So I'm going to need an offset. And I'm going to also use an offset for the flakes touching his head, but we'll talk about that another time. But the offset for the left and right, we'll use that to, well, we can just do the left and right check without the offset. How about that? Pretty simple. So if we're moving this direction, we can move him, increment him, and then we can check to see if he is 0 or less, and then we can set him to 0. Yeah. So if P rect is minus equal to 0, yeah, and we'll just set him. So if he's sorry, is he, that's not right, is it? So if rect x is smaller or equal to 0, we're going to set it to 0. And the other side, when it's going right, if it's bigger or equal to the off screen. Well, let's just say, we don't even have to say equal, we'll just do that. That's good enough. If P rect dot x, and this is not right here, this should be an x, not a w, is bigger than window width, then we will set it to window. Well, okay, so on this one, we can't say x, we need x plus width. So it's going to be p rect dot w. So if those two, if x plus width is bigger than window, spelled totally correctly, window width, then we need to set rect x to window width minus the width of the character. So we need to set p rect.w, sorry, x equals window width minus p rect.w. So I hope this makes sense. So the x plus the width is the right side of the player. So we're checking if the right side of the player is bigger than the window width. If it is bigger than the window width, then we need to set x, which is the left side of the player, because that's the one we control, is x. We need to set that to what, we're trying to get the right side of the player still on the screen. So we set the width, which is say 800, minus whatever the width of the player is, and that's going to get us to where the x should be. So let's see if that was all written correctly. So this should stop, see? And it stops where the snow is in the base of the snowman. And over here, and that's perfect. So it is stopping on both sides. Later we will make these a little tighter, and it'll be slightly more complicated, but for right now this works perfectly. Yeah, so that gives us our moving player. So let's just do a real quick recap of what we have going on here. Oops. I believe that's just fine still. Yeah. So so the actual resources are all being held and managed in game. So the game struct is holding on to the player image, and the game struct is holding on to the pointer to the actual player on the heap as well. The player is holding a local pointer to the render and to the image, but it's actually not managing them. So when we clean up the player right here, we're just setting things to null. We're not actually destroying anything. We're setting them to null. This is just an internal array anyway, so we're just setting them to null. But we do have this calloc of the player itself on the heap, so we're freeing that. We're setting that to null, and that null is actually not a local pointer null. That's the null inside of the game struct. And then we don't need this anymore. So that is how we free the player. We're creating the player the same way with the calloc and checking, and then we're just passing the render that we passed in and the image that we passed in. We're setting it, and we're getting that pointer to the internal array and keeping it in our variable there. We are querying the texture here inside of player because we're holding the rect locally. We're not holding it in game. It's not something we're managing. We just need it here, so we're doing that. We have this flip variable that can be SDL flip horizontal or none. We're not going to be flipping vertically. We're just putting X in the center of the screen. Unfortunately, the Y is a magic number just to get us in the right spot. We're using the key state to move the player left and right. Later on, we will be making this delta time and stuff. This will be a little bit more complicated. And the player does draw itself, and we're using the render copy EX so that we can flip the left and right. But other games, if you wanted degrees and stuff, you could use this. You could do different things. And let's save this. And then from game, we're letting the player draw itself. Inside of here, we're clearing the render, we're drawing the background, then we're drawing the player on top of the background, so the player is drawn after it. It goes in order. So if we draw 10 things, the one that's drawn first will be in the back, the one that's drawn last will be in the front. So it's background, it's player, and we are updating in between the checking of the event. We're going to update everything here, and then we're going to draw everything here. So that is going to be it for this video. Hope you enjoyed that, and we will be continuing on in the next video. So bye for now.